this is Nathalie. Hi, this is Evelyn, blah, blah, blah. Today we have an extra guest, and she's special. Her name is Jigglypuff. Hi, my name is Jigglypuff, and I'm going to help you in an experiment. Today we are going to do a lemon battery experiment to study how chemical energy could transfer to electrical energy to light energy. Lemon battery consists of two different metals suspended in an acidic solution. Copper and zinc, copper and zinc, work as well as the metals and the contents of a lemon will provide the acidic solution. Remember my pH indicator experiment I did a few weeks ago? What color did the pH indicator show, and what does that mean? Let's find out. For this experiment, we will need 2 large, fresh, juicy lemons. Cheers! Cheers! Copper metal strips. Say copper. Zinc metal strips. Say zinc. An LED light bulb, which you might have seen in Makerspace, and a voltage meter. Here it is. Step 1. Creating the battery. First, we use the palm of our hand to press and roll the lemon firmly on the table. This extracts more juice inside the lemon. To make the lemon battery cell, we insert a copper metal strip into a cut on one side of the lemon. Push a zinc metal strip into the other side of the lemon. The 2 metal strips must not touch each other.
They shouldn't touch, right?
Yeah,
like this, like so.
Yeah.
They're not touching, yeah.
Yeah, like so.
Like so.
Okay, so we connected the lemon, right?
Yeah.
What is the voltage on here?
About 0.9.
0.9. Okay. So how much voltage do we need for light up this little guy?
We need 1.5 or more.
Yeah, 1.5. So we need to add. Looks like we need to add 1 more lemon. Yeah.
Yeah.
So let's work it out. You get it rolling. We got to do it in next step. So 1 lemon is not enough.
Yeah, so we have 2 lemons.
So we have 2 lemons. So we just added 2 lemons here. Right.
But
So
3 lemons is too much.
Pardon?
Tip, 3 lemons is too much.
No, well, 3 lemons, we're going to add more voltage. But I think for what we're doing here, we just need 1.5.
Okay.
A little bit more is fine. So what happened is we have 2 lemons here. On the black side here, on the black is the zinc. And then on the red is the copper. All right, we've got to make a circuit here. So what you have on your side is the copper. What you have on your side is the copper. So can you put it on the one side, on your side, on the lemon one?
Here.
Yeah, you put it on lemon one.
Where's the scar?
Okay, and Evelyn, can you put the zinc on the other?
Scar.
On the other side, on the other end.
Here, yeah. Here, just now.
Okay, okay, let's see what we have. Wow, so we had 0.9 just now, and when we add 2, what do we have?
18.
Not 18, 1.8.
1.8.
So we have 2 lemons of 1.8 volt, and should be powerful enough to light this up. So what we have here, we undo this and undo this. And have you got the LED? The long one goes to the positive. Okay, so we have 2 cells together finally. It was quite hard to do the clips. And we see here the red LED glowed. So the 1.5 volt is going through with the 2 lemons. Okay? And we proved that by connecting more lemons, you get higher power. So if we have 3 lemons or 4 lemons, this light will be much brighter as well.
There's a chemical reaction between the steel and the zinc metal strip and the lemon juice. There's also a chemical reaction between the copper metal strip and the lemon juice. These two chemical reactions exchange electrons and push through the wires. Because the two metals are different, the electrons get pushed harder in one direction than the other.
This photo is to demonstrate that the zinc pushes harder against the copper.
If the metals were the same, the push would be equal and no electrons would flow.
This photo is to demonstrate that if it's two zinc electrons, the pushes will be very equal and there won't be any electric current going.
The electrons flow in one direction around the circle, then come back to the lemon battery. While they flow through the LED, they make it work. This flow is called an electric current.
Electric currents.
Now, this is to demonstrate how the electron moves through the circuit in the lemon battery. So we have zinc, which is Nathalie, and we have copper, we have Evelyn, and we have wire and the LED, we have Mum here. Okay, so how the electron goes? Well, it gets from negative to positive. So Nathalie will get a ball, to represent the electron. So the negative goes to positive, and it goes to the wire. So Nathalie keep getting balls, new balls, and keep going, keep swapping, and Nathalie get new ball again. Yes, keep going. So this is how the electron rolls. Nathalie keep getting new balls, pass out new balls, because I'm asking Nathalie to passing out new balls because the zinc actually giving out the electrons, and it goes through to the copper, and the electron goes to the wire and the LED to keep the LED glow. So this is how one lemon works. Okay?
When the two lemon cells are connected together, the lemons work together to create a higher voltage or electrical force to light up the LED.
Okay, now we have the whole family here to help. So we've got lemon group 1 and lemon group 2. So what happened is we have two lemons we just did in an experiment, and that's how the current goes. So Nathalie, you start with a ball. Okay, then you pass to copper, and copper pass to zinc lemon number 2, and they add 2. So this is how they add the voltage, and then back to the LED or the wire to make it bright. So keep giving 2. Very good. And then they keep adding. So basically they're adding up balls to two balls. Yeah. And then they add. So basically there's 2 balls going through, which is double the current. So this is how the electron works.
The more lemon battery you connect, the higher voltage it becomes, as we have compared them between 1 and 2 lemon batteries. Who invented battery? The lemon battery is a type of photo factory, which was invented by an Italian physicist chemist, Alessandro Volta, in 1799. He is a pioneer of electrical science. He invented the first electric battery, which then people called the photovoltaic pole in 1800. I hope you have enjoyed this experiment as much as I do and learned more about how battery works with some history. Until next time, bye!